everyone, welcome to Chemazon-Complete Chemistry. So now for today's video we're going to solve question 54 of the JAM 2022 chemistry paper. Total degeneracy, that is the number of microstates for titanium 3 plus ion in spherical symmetry is. So let us try to understand first what is the meaning of a microstate. Now what is microstate? Microstate is nothing but it is the arrangement of an electron. It is arrangement of an electron in an orbital of subshell. Now we will understand the meaning of this a little later. Before that we have to find out what are the different steps to find out microstates. Steps of finding the microstate. Okay, suppose an electron can be either clockwise like this, it can be oriented like this, and it can be in any orbital. If we consider d orbital, there are how many? For a d subshell, there are how many orbitals? There are 5. If we check the angular momentum values, it will be +2, +1, 0, -1, and -2. Okay, so these two orientations can be aligned in different ways in this orbitals, and those arrangements are nothing but they are called as a microstate of an electron. Okay, so what are the steps for finding the microstates? The first step is write down the electronic configuration. Write down the electronic configuration of whatever ion that is given to us. Okay, let me erase this. So which ion is given to us? Titanium. What is the atomic number of titanium? Scandium titanium. Atomic number is what? It is 22. So what is going to be its electronic configuration? Ar, that is argon is how much atomic number? 18. We want 4 more electrons. Ar 3d2 4s2. 18 plus 4, the total is 22 electrons. So this is the electronic configuration. But we have to find out the microstates of titanium? No, we have to find out the microstates of titanium 3 plus. What is the meaning of 3 plus? 3 plus means we have to remove 3 electrons from titanium. Remove 3 electrons from titanium, and always remember, whenever you remove electron, you start from the outermost orbit that is given, because the electrons are loosely bound. So first what we will remove 2 4s electrons, and then we will remove 1 3d electron. So what we are left with? Ar 3d1, and we are interested in what? We are interested only in this d1 configuration. So what configuration did we get? D1. And for D1 we have to find out the microstates. Now what we can do, we can use the formula. Second step is, what is the step 2? Step 2 is use the formula to find out the microstates. Okay, so what is the formula for finding out the microstates? The number of microstates are given by, it is equal to n factorial upon r factorial into n minus r factorial. Now what is the meaning of n and r? Let us first see that, and then we will also see what is the meaning of factorial. N is the total maximum number of electrons that can be occupied in a subshell. Now what is the meaning of this? Suppose if I talk about s orbital, there is how many orbitals in s subshell? There is only one. And in one orbital, how many electrons I can fill? 2 electrons. So for s, if I tell you To find out the value of n, it will be how much? 2. For p, if I want to find out, p has how many orbitals? 3. px, py and pz. So each has a capacity of 2. So 2 plus 2 plus 2, total of 6 electrons. Similarly for d, there are 5 suborbitals. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Total of 10 electrons. Similarly for f, there are how many orbitals? 1, 2, 3, 4, 5, 6 and 7. So again total how many electrons for an f orbital? It will be 14. 7 to the 14. So this was the n value. And what is R? R is the electrons to be filled. Here what is the value of R? R here it is going to be 1 because we have D1 configuration. Okay, so now we can find out the microstates. Number of microstates will be how much? N. What is the value of N here? N is for d orbital. How much is the value of N? Total maximum it can have 10 electrons. So N is 10. And what is going to be R? We want to find out for D1. So R is going to be 1. So N factorial means 10 factorial divided by R is 1 factorial into N minus R. N is 10 minus R is 1 factorial. So this is 10 factorial upon 1 factorial into 10 minus 1 is 9 factorial. Okay, now the question is how do you solve this factorial thing? Okay, let us see that as well. So let me start with 10 factorial. If I want to find out 10 factorial, what I will do? 10 factorial is 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. You start from this number and end when there is 1. When you get 1. 9 factorial is going to be 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Suppose I want to find out 8 factorial. Similarly, you can do till 1 factorial. 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. In this way, you can find out the factorial. Suppose I want to find out for 5 factorial. How will you do? 5 into 4 into 3 into 2 into 1. Start from the number that is given and end when you get 1. Suppose I want to find out 1 factorial. What is going to be 1 factorial? It's 1. One more thing you must remember, what is the 0 factorial? It is a property. 0 factorial is also 1. Okay, so now we can find out 10 factorial. I can write it as 10 into 9 factorial. If you see this entire thing 9 into 8 into up till 1, this is what? This is 9 factorial. So instead of writing from 9 into so and so till 1, I've written what? I've written 9 factorial. Why? Let us see. 1 factorial is 1 into 9 factorial. Why I've done that? So that I can cancel 9 factorial with 9 factorial. And what is going to be the final answer? 10 divided by 1 is 10. Okay, so this is the mathematical part. Now, suppose I want to understand the physical significance of this, that how there are 10 different arrangements. Okay, let me erase this. Okay, so now we have got what is the correct answer. Correct answer here it is 10. Now I want to find out how there are 10 different possibilities. Okay, let us see that. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. What are the ml values? For all it is same, plus 2, plus 1, 0, minus 1, minus 2. Similarly here also 1, 2, 3, 4, 5. Okay, so let us consider first which spin, the clockwise spin, that is this. Okay, there is only one electron. Okay, we have to find out how there are 10 different possibilities. So either the electron can be in plus 2, okay, or the electron can be in plus 1, or the electron can be in 0, or the electron can be in minus 1, or the electron can be in minus 2. So this way we got how many possibilities? 5. Now let us draw the other 5 as well. Okay, so now we can draw for the other 5. Now what will be the electron configuration? Now let us consider it as clockwise. This was which spin? This was plus half spin. Now we are considering minus half spin. What is plus half and minus half? It is the ms values, spin quantum number values. Okay, so now I can have minus, this is plus 2, plus 1, 0, minus 1, minus 2. So electron can be in plus 2, plus 1, 0, minus 1 or minus 2. Now here, okay, so these are the remaining 5 possibilities. So 5 plus 5, in this way we get the total of 10 different microstates. Why we have derived this formula? Why we had derived this formula of microstates? Because what was the formula? N factorial upon R factorial into N minus R factorial. Why I have derived this formula? Because this is only one electron. Suppose there is D5, D9, then it is going to be very much complicated to draw such electronic configurations for each and every electron. Then every electron will have two types of spin. One will be clockwise, another will be anti-clockwise. So it is going to be very lengthy. That is the reason we use the formula. So what is the correct answer for this question? It is going to be 10. I hope you have understood what is the meaning of a microstate, the physical significance, the formula that is to be used, and why do we use it. Thank you.